Imagine for a moment that you run a lemonade stand and you have to decide between two things, how much labor you would like to hire and how much capital you would like to hire. So in all the previous examples, we've kind of assumed labor was the only thing that we were dealing with, but this is the factor market. So we deal with hiring labor and hiring capital. In any one of those examples, perfectly competitive or otherwise, we could say it was capital as well. So this is the supply and demand for capital. This is typically what's called the wage or the rental rate for capital. And let's say it's perfectly competitive. So this is the marginal factor cost for capital and the downward sloping demand for capital, which is the marginal revenue product. And this is how much capital I hire. And so I can hire, that's my profit maximizing number of capital. But in this one, we're saying we could hire labor or we could hire capital. How do I know how much of each one to hire? I might be able to figure out my total based upon marginal factor cost and marginal revenue product. But in this one, I want to know what's the least cost I can have with hiring labor or hiring capital. So in order to do that, what we're going to take a look at is some things that we've not yet done. And so some of it's going to be the same. We're going to have kind of our, we'll compare like this. We could hire 1, 2, 3, 4, or 5 people, or we could hire 1, 2, 3, 4, 5 machines, the lemonade mixer machine. And what we know is that no matter if we're hiring capital or hiring people, we know that there's diminishing returns to labor. So this is my quantity of labor. This is my quantity of K is capital in economics. And I know that I have a total product and I have a marginal product of labor. I know I have a total product and a marginal product of capital. Let's erase some of this so it's easier to see. All right, so what we're going to take a look at are things that we've done in the past. And what we're going to try to do is determine how many I should hire of each one of these. What's the least cost I can have? What we're going to do is, in this example, say we have $25 to spend on hiring capital or hiring labor. Should I hire all capital, 2 labor and 1 capital, or what's the best combination with the least cost to get the most output? And so for my capital, we're going to have diminishing returns to capital as well. So our capital, well, we'll start with labor. Our total product for labor is going to look like this. We're going to go 20, 35, and then we're going to go 45 and 50 and 52. And for capital, we're going to say that it is our total product for capital is going to look like this. We're going to be 20 and 35 and 45 and 47 and 48. And so the next thing that we want to do is find marginal capital or marginal product of labor, which is the next one, which is just how much extra output I get from one more worker or one more machine. And so this is going to be 20, 15, 10, 5, and 2. And for capital, it's going to be 20, 15, 10, 2, and 1 is going to be the ones that we have. Now, here's the trick. What we want to know is how much output do we get from the last one? So how much marginal output do we get for every dollar that we have to spend in order to get it? So remember, over here we have to pay a wage, and over here we have to pay what's called a rental rate. Because just looking at this, it looks like, well, they're kind of basically even, right? So I get 20, 15, 10, 5, and 2. I get 20, 15, 10, 2, and 1. I don't know. I could hire either one of them. But here's the trick. We're going to say that labor costs $10 to hire. And my lemonade mixer machine, we're going to say costs $5 to hire, $5 to get. So again, here's the big concept right here. I want to know how much does it cost me to get that? And how much does it cost me to get that? Right? Well, it cost me $10 to get this 20 on this side, and it cost me $5 to get this 20 on this side. So which of the two should I hire first? Well, I can hire this one over here and spend $5 and get 20 units of output. Or I can hire this one over here and get 20 units of output, but I have to spend $10. So we're going to buy this one over here first. And so how do we look at that in kind of simple and very simple way? I want to know the marginal product that I get per every $1 that I spend. And then I'll be in common terms in this last column. So we're going to call it marginal product per dollar. Marginal product per dollar. So how do we figure that out? Well, what's my marginal product for how much I had to spend for it? So this is 20 divided by 10, which is going to be 2. I get 2 products. I get 2 units of output for every dollar that I spend. And over here, it's going to be 20 divided by 5, which means I get 4 units of output for every dollar that I spend. So yeah, I hire this one first. And then the question is, well, do I hire this one next? Well, I don't know yet. What we want to do is compare. Now I'm comparing between this first one over here and this second one. And I want to know which one's a better deal now. So I can look at the next row and I can say, well, this is 15 divided by $5 that I have to spend, which equals 3. Well, no, actually, hiring the second one over here is still worth it, because I get 3 units of output for every dollar that I spend instead of the 2 units of output for every dollar that I spend by hiring a person. So I'm going to hire another machine. And then I compare again. And here I go 10 divided by 5 equals 2. Well, now I'm kind of indifferent. So it doesn't matter. Do I have money left? Let's see. Do I have any money left? I spent $5 on this one. And I spent $5 on this one, so I spent $5 and $5. So I have $15 left. So can I afford to hire this one? Yes. That brings me down to $10. And then I hire this one? I can. And that brings me down to $0. So I spent all my money. So what we're going to do really quickly is show why this is the best combination. The best combination to hire is going to be 3 machines and 1 worker. And I'll show you a combination where I still spend 25, but that's not going to be the best. It's not going to be the most output. So in this best output scenario, let's figure out how much output I have. Well, from capital, I get 45 units of output, right? The 20, the 15, and the 10. And from labor, I get another 20. So we're at 65 units for $25 that I had to spend. All right, well, let's kind of finish out our charts and see where else we could have spent our money and how much our output would have been. So this one, 2 divided by 5, those that I spent, equals 0.4. And this is 1 divided by 5, which is 0.2. And over here, this one would be 1.5, 1.5, and then it would be 0.2. All right, so let's say for example, we didn't know what we were doing, and we just decided we were going to spend our 25 and we were just going to buy machines. We're going to buy all machines. So we spent all of our 25. Let's do it in an orange color here. Let's do all of our 25 on 1, 2, 3, 4, and 5. So we have our 5 workers. We spent our $25. So we spent all of our money, but what's our output? Our output is 48. So we spent $25 for 48, where if we would have had a different combination, our 3 capital and 1 worker, we would have gotten 65 units of output. Well, that doesn't make any sense. We want the least cost for the most amount of output. So let's try maybe a different combination, because that 25 didn't work. So let's say instead that what we decided to do was 2 workers and 1 machine. That also equals 25. So how much output do we get from 2 workers? From 2 workers should be 35. We spend our $25. We got 2 workers, which gives us 35. And we get 20 units of output right here. So 20 right there, which gives us a grand total of 55. Well, we spent all of our money. We had 2 workers and we had 1 capital, but we only got an output of 55. Right? So there's one combination that's the least cost and the most beneficial. And that's going to be where what we're spending our money on, the marginal product per dollar of labor equals the marginal product per dollar of capital. Now, if this rings a bell to you, it should, because this idea goes back to the same thing when we talked about balancing, let's say, apples and oranges. And when we eat just apples, 1, 2, 3, 4, our marginal utility starts to drop as I eat more of them. Let's say it's awesome, it's a little bit less awesome, it's not as good, and I really don't care about it that much. And same thing with oranges, 1, 2, 3, 4. My marginal utility that I get from each orange, it's amazing, it's okay, it's fine, I don't really want it anymore. And let's say apples are, I don't know, let's say apples are $1 and oranges are $2, right? So which of the two should I buy first? Well, we do marginal utility per dollar versus marginal utility per dollar, and we compare the two. Well, marginal utility per dollar over here would be 10, 9, 5, and 1, and over here it would be 10, 5 halves, or 2.5, and 1/2. And then we can compare. And we say, well, between the first two, it doesn't matter. They're both good. They both give me 10 utils per dollar. But then after that, I should definitely have a second apple. And after that, they're equal to each other. And after that, I should definitely have the orange. And that's maybe my best combination between the two. So if we had, 1, 2, 3, 4, 5, 6, 7, 8, $9 to spend, that would be our best combination to get the most utility. And so this idea of marginal something, marginal utility, here it's marginal product per dollar, it should equal the marginal product per dollar of the other good. And then when you spend all of your money, if those two things are equal to each other, then you've maximized, you've had the least cost. Okay, so this is the most important kind of concept out of this one, is you find margin utility per dollar. So for example, last thing, if we know that the margin utility or the marginal product, of the last worker hired is 50, and I spend $10 per worker, and I know that the last, let's say, marginal product of capital I have is 200. If I'm using least cost, what is the rental rate for machines? What is X? Well, this would be just kind of some simple math to say this is 5 equals 200 over X, right? And so if I multiply by X and multiply by X, and X equals 200 over 5, so X equals 40. And so I would know that if I am using the least cost rule, that the rental rate must be 40, because the marginal product per dollar equals the marginal product per dollar for capital.